Good evening. Now we will see the problem which is on design of laterally unsupported beam. So we have question design laterally unsupported beam for the following data. Loads are packed on it. So we have given a simply supported beam. We have load on this beam that is 30 kilonewton per meter. And central load we have 50 kilonewtons. 3 meters. And then we have to solve this. Now we will go for this, that is solution. So given data, so we have as shown in figure, given data as shown in figure. Central we have 50 kilonewton. That all are packed to it, and this value we have 30 kilonewton per meter. Then this is step 1 given data. Step 2 we have bending moment. We have mu is equal to WL square by 8 plus WL by 4. So we have 30 into 6 square by 8 plus 50 into 6 by 4, and this value comes 210 kilonewton meter. Then we have step 3. Section modulus required. So we have to assume FBD. So 6 meter we have seen, we have assumed FBD 110. Therefore ZP required mu upon FBD. And then mu we have 210 into 10 raised to 6. FBD we have 110. And then if we will see this required value of ZP, we have 1909.09 into 10 raised to 3 millimeter cube. Now we will go step 4, selection of section. Selection of section. So we have considered ISMB 500. So how we will select this? You can see this 1909. So we have this value ISMB 500. You can see this, we have this value 2074. Therefore, we have selected this value. So we have ISMB 500, and that is 86.9 kg per meter. Now I will calculate values tentatively. So I have TF 17.2 millimeter. RYY we have 35.2 millimeter, and ZPZ 2074.67 into 10 raised to 3 millimeter cube. Now you can see this. We have KL upon RYY 6000 divided by 35.2. We have this value 170.45, and HF upon TF. So we have H minus TF upon TF, and that is equal to 500 minus 17.2 upon 17.2, and this comes 28.06. So now we will consider this value 170.45. So we have seen KL upon R 170.46, and HF upon TF we have 28.06. Now we will take KL upon R, that is 170, and then for 25 and 30, so we can have for 25 and 30 these values. So we have KL upon R 170 and HF upon TF 25, 30, we have 136.7 and 121.3. And if I will consider center of this, and therefore I will take FCRB equal to average of the two, that is 136.7 plus central value I will consider very close. I am just checking first. And this value comes 128.5. Now, knowing this value 128.5, I will go to FBD. So 128.9, 128.5. Now you can have this 100. FCRB we have 150. And for this I have value that is for 250. 106.8, and for 100 this value comes 77.3. Again in the center I will consider. So for 125 I have value of FBD, because 128 and 125 close, so we can have this value that is approximately 92. And then if I will find MD, then I have 92 into 2074.67 into 10 raised to 3. Then this comes 190.87 into 10 raised to 6. But this value is less than 210 into 10 raised to 6 Newton millimeter, and therefore revise section. So do not go in detail first. So we have to revise this section, and now I have considered section that is ISMB 550. Now we will go little bit detail. ISMB 550, you can see over here ISMB 550 at 103.7 kg per meter. Now we have to go in detail. Then we have KL upon R, that is 6000 upon RYY. You can see over here we have 37.9. 37.9. You can see over here for 550 this value comes, 37.3. 37.3. And from this we will get this value, that is 160.85. Then we will find HF upon TF. Now we have 550. Now you can see TF, we have 19.3. minus 19.3 upon 19.3, and this value comes 27.5. Now you can have question where we will go for 2711.98. We can have ISLB which is actually 2228. But what happens if you will see, you have this TF 15, and if you will go HF upon TF, it becomes higher side. And you can see this, if you will go on higher side, then your value of FCRB go on reduces and your FBD reduces. And therefore, I have not taken ISLB 550, I have taken ISMB 550. Now we will calculate values detail KL upon R. We have 160 and 170. And then we have HF upon TF, that is 25 and 30. Now values we have 148.2, you can see over here. 148.2 for 160. You can see we have these four values. 132, then 136.7, and then 121.3. And then if you will calculate this value, I will calculate it for first 28 point. So we have 27.5, sorry, 27.5. So this is exactly average of the two, and we are going to get for 27.5. These two values, I will just change the color. So we will get this value 140.1. And if you will take average of these two, you will have 129. And then calculate value that is for 160.85, and we will get this value of FCRB, and this value comes 139.06. Knowing this FCRB value 139.06, so now I have FCRB 139.06 by using table 13A, which is for rolled section. I can find value of FBD. Now FCRB we have 100 and 150. For 100 we have value 77.3, and for 150 we have 106.8. I am not calculating the value, you can calculate it. For 139.06 we have value 100.49. 100.49. So now knowing value of FBD, so this is value of FBD 100.49. We can find value of MD. So we have, that is next step, step 6. So design bending strength. Step 6, design bending strength. And then we can have this MD is equal to beta B ZP into FBD. Now beta B1, ZP we have 2711.98 into 10 raised to 3 into 100.49, and this comes equal to 272.53 into 10 raised to 6 Newton millimeter, which is 272.53 kilonewton meter greater than 210 kilonewton meter, and therefore safe. Then we have last step, step 7, check for deflection. Check for deflection, and then we have delta calculated. So for UDL 5 by 384 WL cube WL4 upon EI plus WL cube upon 48 EI. So these are working loads. So we have 1 upon EI, we will take common 2 into 10 raised to 5 into 53095 I 53095.5 in bracket 5 by 384. Then we have 30 upon 1.5 into 6000 to the power 4 plus 50 upon 1.5 into 6000 to the power 4 upon 48. And if we will calculate this value, we will get 4.6 millimeters. And we have delta allowable span by 150, and then this will be 6000 upon 150, and this comes 40 millimeters, which is greater than 4.6 millimeter. Therefore, okay, provide ISMB 550. So this is all about your problem, that is design of laterally unsupported beam. So now we will stop here only. Thank you.